All right, let's dive right into this. Welcome to This Explainer. When you think about electronic music, beat making, or sequencing, your mind probably jumps straight to modern recording studios, right? Glowing computer screens, complex software, maybe a massive mixing board? But what if I told you the very first blueprint for a programmable drum machine wasn't sketched out in some shiny modern tech hub? No, it was actually designed in a 13th century royal court. Today, we're exploring an 800-year-old invention by an engineer named Ismail Al-Jazari. And honestly, it completely challenges everything we think we know about the origins of automation, programming, and music tech. Picture modern beat making for a second. Today, a producer opens up a laptop, taps a screen, drags a digital sound onto a timeline, and boom, a musical pattern is instantly created using microchips and code. Okay, now contrast that with medieval beat making. Instead of a high-res screen, you've got physical wooden pegs. Instead of microchips, you're working with mechanical levers. And instead of plugging into a wall for electricity, you're relying on the sheer brute force of water power. It sounds like something straight out of a steampunk fantasy novel, but the astonishing reality is that both of these workflows were designed to achieve the exact same goal, creating a repeatable, programmable rhythm.
So, Section 1. Meet Ismail Al-Jazari, a 12th century absolute genius.
Now, Al-Jazari wasn't just casually tinkering in a workshop. He was a visionary mechanical engineer who was completely obsessed with automatic movement. In his famous 1206 treatise, The Book of Knowledge of Ingenious Mechanical Devices, he documented a truly staggering array of inventions. We're talking incredibly precise water clocks, complex pump systems, trick fountains, and literally mechanical servants. He was masterfully combining hydraulics, cams, and gears in ways that were centuries ahead of their time. But for our explainer today, we are going to focus entirely on his musical automata. Okay, I really want you to picture this scene. Imagine a grand royal gathering right beside a perfectly calm pool of water. The guests are relaxing, talking, enjoying the atmosphere. Then suddenly, with zero human intervention whatsoever, a band of 4 mechanical musicians springs to life and just starts performing. According to Al-Jazari's incredibly detailed descriptions, this robotic band was made up of a harpist, a flutist, and 2 drummers. They were designed specifically to entertain the court. But the real marvel here wasn't the ornate figures themselves. It was what was happening hidden, completely out of sight. Which brings us to Section 2, the mechanics of rhythm. Let's look under the hood. Let's walk through this mechanical choreography step by step because it's fascinating. It all starts with water. The continuous flow of water powers a wheel. That wheel then transfers its energy to rotate a central axle, which in turn rotates a long wooden cylinder. Now, wrapped around this rotating cylinder are small little projections, basically wooden pegs. As the cylinder continuously spins, these pegs move past a series of mechanical cams and levers. When a peg hits a lever, clack. The lever moves, which yanks the mechanical drummer's arm above, causing it to strike the instrument. So water power transforms into mechanical rotation, which becomes linear movement, which ultimately becomes music. Every single movement had a beautifully precise, calculated purpose. The most crucial part of all this is how it actually generates a specific rhythm. Because the timing of everything is controlled mechanically, the placement of those pegs on the rotating cylinder is literally everything. If you put the pegs in one specific physical arrangement, they're going to hit those levers at exact predetermined intervals. The result? You get a rhythmic sequence. Boom, boom, clack, boom. And the machine will flawlessly repeat this sequence over and over, as long as the water keeps flowing. But here is where Al-Jazari's machine crosses the line from just being a cool mechanical toy into a legitimately programmable device. If you take that cylinder and you physically move the pegs to different holes, actually changing their arrangement, you completely change the sequence. Now, the levers are struck at different times, and you get an entirely new beat. Boom, clack, by simply rearranging physical components. You are actively giving the machine a new set of instructions. That physical arrangement of the mechanism acted exactly like a primitive musical program. Moving to Section 3, a new definition of programming. Talk about a paradigm shift. So what does the word programming actually mean? At its most basic level, programming is just giving instructions to a machine so that it performs a desired sequence of actions. When we hear that word today, our brains immediately default to code, algorithms, memory chips, processors. But fundamentally, at its absolute core, programming does not require electricity. It doesn't require Python or C++. It literally just requires a way to store instructions that a machine can execute. Al-Jazari didn't have software, right? He had movable wooden pegs, but he was undeniably programming. Let's compare the ancient to the modern one more time, just to really let this sink in. Al-Jazari's workflow relies on a physical track. Pegs trigger levers, which trigger mechanical percussion. Now, think about a modern drum machine, like those legendary Roland rhythm machines that basically built modern electronic music. That relies on a digital track. A software program triggers electronics, which trigger sound generation. The physical materials are completely different, literally centuries apart in technological evolution, but the underlying architecture of thought, the idea that you create a pattern, store the pattern, and let the machine repeat it, it is exactly the same. Now, we definitely need to remain historically grounded here. Based on the rigorous work of researchers like Professor Noel Sharkey, our understanding of this machine comes directly from Al-Jazari's detailed 1206 illustrated treatise. Modern researchers have beautifully reconstructed how it worked based on those ancient texts. So to be perfectly historically precise, we aren't saying the guy built an electronic drum machine in the Middle Ages. Rather, he described and designed a mechanical musical automaton that could be configured with movable pegs. That makes it a profound, undeniable early precursor to the entire concept of programmable music.
All right, section 4, from pegs to pixels. Let's talk about the legacy here.
We can trace this incredible lineage of instruction storage right through history. Back in 1206, Al-Jazari stored instructions in cylinders and pegs. Jump forward a bit to the 18th century and you've got music boxes doing the exact same thing on a microscale, using little pinned metal cylinders to pluck teeth. By the 19th century, player pianos were using long punched paper rolls to store complex musical data. Again, a physical pattern telling a machine what to do. And finally, we arrive at modern tech, where that physical pattern becomes microscopic electrical charges stored in digital memory. The mechanism itself evolved drastically over time, but the core philosophy of physically storing a pattern for a machine to follow, that remained completely identical. So why does an 800-year-old machine actually matter to us today? It matters because Al-Jazari proved that highly sophisticated engineering concepts, things like automation, sequencing, mechanical programming, using cams to control precise timing, and even simulating human-like movement, did not begin with the silicon chip. Long before the computer age, long before electricity, human beings were successfully building automated systems that could act according to configurable instructions. Honestly, it is just a massive testament to the incredible depth of human ingenuity.
Which leaves us with a pretty fascinating final thought to ponder. We have gone all the way from wood and water to silicon and electricity. But as we know, technology never stops evolving. The future of tech often has its deepest roots in the imaginations of the past. So, if the very concept of programming began with water and wood over 8 centuries ago, what entirely new materials and invisible forces will we be using to program the machines of the future? Thank you so much for joining me for this explainer. I really hope it completely shifted the way you look at the origins of our technology. See you next time.